Good evening, sir. This is my personal timetable, and I attend a research group meeting on Monday, and I uh, attend HFSS class on Wednesday, on every Wednesday, and I did coursework also, and I have made assignment of big data, and this I have done, and next bit done in next week. And today I'm just briefing about big data. What is big data is it refers to a large amount of data in which pouring in form of various data source and different format, and it is important assets which can be used to obtain numerous benefit. And it is three different format of big data: structured, semi-structured, and unstructured. In structured, organized data format with fixed schema, RDBMS, relational database management system, that is. And semi-structured is a partial organized data which is not have a fixed format. Data can be signed in a form of XML and JSON. And in unstructured is unorganized data is unknown schema, like that can be an audio and video file. As you can see in this picture, this is a V5s of a big 5 V's of big data, that is validity, variability, vulnerability, visualization. Validity is correctness of data, variability is dynamic of behavior, and vulnerability is a tendency to change in time. Vulnerability is vulnerable to bridge the or attacked, and data is vulnerable. And visualization is visualizing meaningful usage of data. And big data application has been adopted by many uh, big data application has been adopted with many domains like entertainment field, insurance, travel as car, education, automobiles, government. In entertainment, Netflix is there, Amazon is the big example for this big data. And driverless car is a Google driverless car collect all about gigabytes of data per seconds. And in education, it's a learning powered technology as a learning tool instead of traditional lecture method which was done in previous and back early years, which has enhanced his learning of student, and aided the teacher to track their performance better also. And automobiles is like Royal Russia has embrace big data by filtering hundreds of sensor into its engine and polarization which record every tiny details about the operation. And government also has adapted for political analysis and influence election results. Also, many countries had adapted this big data for election purpose, like China and UK. And what was the scope for the big data is like numerous job opportunity raises, profile in field of you can see that in field of in field of big data. And files such as big data analysts, big data engineers, and big data solution architectures, and like that. Rising demand of for analytical professional, and salary expects and adoption of big data analytics. Now this is my thesis topic, radiometric thermometer for variable deep tissue monitoring. In this chapter was measurement result. In this chapter I have gone through with many things like There was several measurement for multiple layer tissue phantom and performed to validate the concept or near field microwave thermometer. As you can see in this picture also, uh, sorry for the interruption. Uh, uh, as you can see in this picture also, two different probe were tested for operation in quit 1.4 gigahertz folded dipole, and there is a circular patch also, uh, which is ground plane, which reduce interference as minus 15 dB return loss of bandwidth of 20 megahertz when placed on phantom tissue. The dipole has wider bandwidth 250 megahertz and susceptible to RFI. Dipole is fed by the Tremblay and fabricated of Roger 435B, and patch is fabricated on Roger substrate. Reduce the sensitivity of probe to the surrounding media, which is advantageous for complex and variable tissue thickness. And next is this as you can see in this block diagram also, there is a single layer, this is single layer measurement have been done, and the probe is placed on the top of the water phantom and connected to the radiometer and external hot and cold noise source. The output voltage is amplified with an added DC gain attached to the National Instrument PCI 614 simultaneous sampling for multifunctional data equation. The output is displayed using the computer programming like a Python script, and the unseparated thermocouple monitored temperature logged by a Pico technology TC08 data log unit. Computer control the DC supply, which controls the noise source and switch. And you can see in this picture also the photograph, which measures a connectorized radiometer with 1.4 gigahertz folded dipole probe placed on the surface of the tap water phantom, and the measure goal was for water temperature with the radiometer. And as you can see this graph, which is this graph is like calibrating a radiometric estimate of direct simultaneous temperature of water tap and half space using the 1.4 gigahertz connectorized radiometer compared to thermocouple measurement. And water phantom is heated to 40 degrees Celsius for the patch probe data and 35 degrees Celsius for dipole case, and the measure were taken as a water cooled under reaching 30 degree. Both probe can track the temperature of the water of about 0.5 degrees Celsius of accuracy. And the table also have fixed measurement, which is a circular patch to short pinning probe weighting function of 5 centimeter. Single layer was this much, and skin weight was 0.64 t. And this is the uh, photograph for the measurement of hybrid radiometer connected 1.4 gigahertz circular patch sorting pin probe. You can see in this picture there is a Picotech data logger also. Data analysis is done, and DC supplies and probe is used, and phantom stack is is there to measure temperature and radiometer inside the plastic bin. And next is a buried layer temperature. In this they were tracking two layer tissue phantom, and as you can see in this picture also, they had there is a two plastic bag filled with the hot and cold missile phantom and cycled and placed on a 2 mm thick skin phantom, and goal is was to only just measure a temperature of unknown muscle phantom with radiometer probe in direct contact of skin. And as you can see in this table also, single layer and two layer muscle 1 and 2 layer muscle 2 weight and their corresponding probe weight, skin weight and muscles weight. Now this graph shows, I'm just going to conclude this graph, both graph. First I'm just going to explain what this line denotes. This blue line denotes the temperature radiometer, and green line denotes muscle temperature, and red line denotes a skin temperature, right? And after that I'm just going to conclude this both graph. First conclusion is radiometer track the subsurface temperature. Second is thermal conduction is categorized by much longer time constant on order of 10 of second, while radiometric temperature is practically intense since it occurs at a speed of light through tissue. And the third is the conductivity of buried layer affect the measurement. Saline solution has a higher conductivity compared with the tap water, and it better molds the electromagnetic property of muscles like this. And next is like this is the buried tissue layer uh, tracking in three layer tissue phantom. And you in this three layered measurement was done, and the same plastic bag is cycled between hot and cold muscle phantom, and the muscle bag is placed on the fat and skin tissues phantom, and probe is connected to the radiometer measurement setup. Next, the only the measurement of temperature of buried muscle phantom under the skin and fat tissue achieved using radiometer probe on the skin. And you can see this table also, what measurement has been done. Probe weight was, and skin weight, and fat weight, and muscles weight. And next is this say in this graph you can see there is a temperature of skin, fat, and muscles, and radiometer denotes a blue line, muscles denotes green line, and fat denotes a black line, and red line denotes a temperature of skin. And as you can see in this first figure, that subsurface temperature detection of muscles under a skin fat tag and muscle tissue phantom in case is saline solution is cycled on 1.4 1.27 centimeter of fat Roger 6010 and 2 mm of skin. Radiometer has sufficient sensitivity to track the temperature of muscles under two other layers also. And in the next figure is the subsurface is long term temperature detection of skin, fat, phantom stack, and radiometric temperature of muscle diode water is compared with real temperature of muscles under a 3 mm of fat and 2 mm of 2 mm layer of skin over a period of around 2.5 hours. And temperature dispense is attributed to RFI, which increase a total power received by the radiometer. And next is done using RFI cancellation. And in this block diagram you can see there is a RFI detection setup is done. A plastic bag filled with muscle phantom is placed on a probe circular patch with sorting pin and substrate is which is connected to the radiometer setup. And additional probe, which is like a circular patch with substrate superstrate, is tracking RF environmental interface. The radiometer is switching between the probe as well as hot and cold noise reference. And next is you can see this adaptive block diagram, noise cancellation also, data from the main probe and data from the RFI probe. And next is this graph shows that first, the black line, you can see there is a thermocouple, and the blue dotted line somewhat there is a RFI filtered, and red line is also RFI filtered. And you can see in this single layer water temperature estimation is done, and with an additional probe and adaptive algorithm compared with incorrect measurement over 11 hours, and direct thermocouple measurement is also in baseline is done. Thank you for the day.